All right, today we're going to be learning about engineering and design. What is engineering? A reminder that this is on page 13 of your Trimester 1 notes, and you'll see that I have a little box here that says type or write, and I want you to type or write the things that are in this box. So what is engineering? Well, engineering is using science, math, and technology to create solutions to solve problems. Sounds simple enough, right? Just remember, science, math, technology, they're all pretty complex in it themselves, right? Science, there's all different types of science. We have biology, physics, chemistry, physical science. We have all different kinds of math. And then when we think of technology, usually we think of like the computer you're on or your phone, but technology technically is any tool that we use to basically make our lives easier, any tool that we have to perform a function. Um, so you could think of like a hammer, a telescope, a ruler. Technically, that's technology. So technology is a pretty broad and vague term as well. But all of these together make up engineering. So there's different types of engineering, and there's 8 total. So you'll see that you have 8 total on your notes here. These are the first 4, starting with aerospace. So aerospace, pretty easy because this A-E-R-O kind of sounds like air, and then of course space. So it is the design, construction, and use of aircraft and spacecraft. Then we have biomedical. That's the design of healthcare equipment. So things like a spirometer or a pacemaker. And if you're like, well, what the heck is a spirometer? It is actually, looks like this. And so you would actually blow into this device, and then it moves this, tells you how much oxygen you are actually holding into your lungs. And so a lot of times athletes will do this. They might have more, you know, technological device nowadays, but I used this when I ran track and field, and they would test your lung capacity. And you could also do it if you're sick too, to test how your lungs are doing. There's also something called a pacemaker. Now, a pacemaker is a tiny handheld device that they actually put near your heart. So you can see that there's a wire that goes to one of your arteries, and that sends electrical currents to your heart. That's only if you need it, of course. Your heart produces its own electricity, but if something isn't working right, you may need a pacemaker to help your heart beat. So the biomedical field creates a ton of cool equipment to make us healthier. Then we have chemical engineering. That's the creation of medicine, food even, fuel, plastics, and more, a ton of stuff. Ton of different products can be made by using chemicals. And usually when we say the word chemical, it kind of sounds very negative. But technically our food is made of chemicals. Chemicals we'll learn a little bit later, but it's not a term that we should look down on. There's of course certain chemicals that are bad for us, but chemicals, the chemical word in itself isn't bad. Then we have civil engineering, kind of a more boring name, but you'll see it every day, everywhere you go. It's the design and construction of roads, bridges, tunnels, everything you see, water systems, your sewage system that you may not even see it's underground, everything in your city, that's civil engineering. Then we have electrical engineering. So that's the design and use of electricity, electromagnetism, and electronics. Industrial is a little more broad. That's the design of efficient systems for big industry. And so that industry could be like a production line of Tamagotchis. I don't know why that came in my mind. If you don't know what that is, like a production line for iPhones, maybe. So if they need like, oh gosh, 100 million iPhones made per year, an industrial engineer might look at its system and go, okay, what can we do to make these faster and maybe cheaper and better quality? Things like that, more business related. Then we have mechanical engineering. And mechanical engineering, of course, has to do with the design and construction and use of machines. Pretty simple. But machine, just like our term technology, can be pretty broad. Technically, what is a machine? Sometimes we think of a machine as like something with lots of levers and gears, but we may learn that machine might involve a little bit more than you think. Then we have software. Software engineering is the design and development of computer technology. So, you'll see a big circle with a bunch of arrows on your sheet. This is called the design process. This is what every engineer must do. So all those engineer types, those 8 types we just talked about, they will all go through this process with their own specific problems. So let's zoom in on one of those engineering types. So recently on Netflix, there's one on Hulu too about Apollo, but on Netflix there's a series about the Challenger, which I haven't finished yet, but it looks very interesting and it got me interested in learning about all the different space programs. So, if you don't know, Apollo 11 is when the US landed on the moon. So you can see that's kind of a crazy picture to think they're on the moon. So I'm going to click on this. Hopefully it'll take me to my link here.
You're looking at one of the most incredible moments in human history. That's Neil Armstrong and Buzz Aldrin walking on the moon.
All right, I'm going to mute this because although it's really cool to hear, I do want to show you how they actually made this spaceship. So this spaceship, you can see, looks like a typical spaceship, right? It'll probably break down its parts here. So it uses a lot of fuel to launch. There it goes. Once it's in space, it actually starts to break apart. Well, that's because it's a very heavy piece of machinery, and a lot of that fuel has been used. So those parts just kind of float off in space. And so what ends up being is the people, the astronauts that are in the spaceship, are in that small piece that are orbiting right now really fast. And so once they get to the moon, it'll actually break down again. Into that module that you see in that picture. Kind of looks like a virus or a spider. So it just kind of sped through all those different parts of the spaceship breaking apart into finally the module that now has to go all the way to the moon, which it does. It looks like that. They land, everything is great and hunky-dory. Armstrong is on the moon. Now, how do they come back? So they actually, let me go back one more time. So you can see they actually set up another launch pad, and they get even smaller. They go into the moon's orbit, somehow reattach to this. Clearly I'm not an astronaut, but they reattach to that, make their way back into Earth's orbit, and what once was this huge spaceship is now just this tiny part and that's where the astronauts are, and that's where they land. And so this is actual footage of them landing back on Earth. Pretty cool. All right, so let's go back to our engineering. Well, if we want to use this engineering wheel, we always want to make something better. So even though that was really cool, we landed on the moon, we came back, what can we do to make things better? Oops, let me go back here. So what is the problem? That's our first step, defining a problem. And you might look at that video and be like, well, I don't see a problem. I look at that video, and because I worry about litter, I say, oh my gosh, what is happening to all those spaceship parts in space? Like, do they just float around? Do they come back to Earth? I mean, these people know the answers, but it's also just a waste. I mean, forget about it. If you don't care about littering, all right, but that's a waste of money, right? That's a waste of material that you can't reuse. It's just lost in space. So you may want to redesign the spaceship so that it can be reusable and not lose as many parts into space. So what is a problem? Very wasteful with fuel and parts in space. At least this is what I think is the problem. That may come down to research. What information do you need to solve the problem? How much fuel do we actually need to launch up into space? I imagine a lot. Can we make the ship lighter or a different shape to make it more aerodynamic? Then we want to create, that's the fun part, create your model or your prototype, and we'll look at prototype, that word specifically a little bit later. So in this instance, we came up with the space shuttle. You can see this looks a little bit different. We still have this huge part that's connected to this other spaceship, but the good thing with the space shuttle is not this ad, but that it can land. So that spaceship in the picture that I'll go back to later, although you launch with all this other material, you can still use quite a bit of this spaceship that has now landed back onto Earth. So I'll fast forward a bit. Landing. Pretty crazy that that was in space. Let's see if I can make it seem too loud.
Gear down. Show the gear lock now. Unofficial touchdown time was 5 days, 2 hours.
So pretty cool. And if you're looking at this going, well, I'm not impressed because it looks just like an airplane, remember that this they had to design to have still enough power and enough strength to withhold going through our atmosphere and being in space. It's crazy. I don't know a lot about space, but that's crazy. So they were able to figure some things out. Now, is it perfect? What works? What problems still exist? That's in our test and evaluate. So this wasn't their first mission. They had other missions, and they had failures. So they had to go back and redesign to make it better. So that's one example of our engineering.